So my name is Aleksandra Klassa. I'm a student of master program Advanced Materials and Processes at the University of Erlangen, Nuremberg. And today I will present you a project which I performed within the Innspace team, which I'm also a part of. And it is a project which we prepared for the Telerobotic Mars Expedition Design Competition organized by the Mars Society. And I need to say we won the second prize in this competition. And I will tell you about the whole purpose of our mission, and mostly focus on the biological part because that's the part which I was mostly involved in. Okay, at first I want to say who is the Innspace team. So we are a group of people. Like the team is, the organization is founded by Justyna Pelc, who assembled a lot of great scientists and engineers and many more professionals in different disciplines. We are all from Poland. And our passion is space, and within the group we take part in many competitions, create some projects, and just contribute to some scientific we create some projects, and one of them is the project about the okay, so at first that is the competition which has the which is organized by the Mars Society. The purpose of the whole mission is to present them the mission of robots, the complete plan of expedition to Mars, and at the same time to have some scientific contribution. And we decided to search for life on Mars, but not on the surface, because as we already know, the Martian conditions, especially on the surface, are very harsh. There is a huge radiation, a huge range of temperatures, and a lot of dust. And in general, the conditions are not very suitable for life. And there is already a lot of rovers on the Mars surface which look for many different things, but they didn't find any life. So we decided that there is something special on Mars, which is not researched yet. Namely, there are lava tubes. There are some geological structures resembling some caverns, some caves, which emerged during the flow of lava under the surface. And it's not only on Mars, we have something similar on Earth. This photo is from Hawaii. And okay, I want to tell you why actually we want to research such a place. Because at the moment we don't really know what's inside of lava tubes on Mars. We know that they exist, but what we really wanted to it's very interesting because as I said, the conditions on the Martian surface are very harsh, but on such a lava tube they don't necessarily need to be that harsh, because the layer of rocks, it already stands some shield from radiation, from this hostile conditions. So if there for some by any chance is some life, or already have been in past, because we don't really know what's inside, lava tubes are much more suitable for such conditions, and maybe also they may be also some water, because it doesn't evaporate that easily. And it's not only interesting in terms of potential life signatures, but also for some future human missions to Mars. It can be also a shield for human. Okay, so now I start talking about our mission, about the whole project. So as I said, Innspace Team is a group of various people. Everybody has his own function in the team. So that's the part that I wasn't involved directly, but I can say more or less how was it designed. So there are different kind of robots. It is planned because it is planned this way because we want to have the very efficient mission, and also they have different functions. I will tell about it. So what you can see on the picture is the big one is a transporter rover. It transports the smaller ones on the right side. These are Boston Dynamics, the walking robots, which can I will tell in a moment what they do. Also, we have some flying robots and mini robots, which are not visible here. So the plan is that we at first the robots are going to make a map of the area, because basing on this we can decide which places are suitable for our search, and which are also interesting. So the flying robots and walking robots, they have some devices like cameras, also thermal cameras, to make a map, which is, as I said, contribution to the mission, but also it creates some maps for future that helps us to better understand the whole red planet. Okay, so if we already have the maps, then we can decide how to search for any interesting things further. Then we have two options. Actually, we can at first we can measure. We can perform some measurements on in situ, don't collecting the sample, or also we can collect a sample and test it in more details. And what we which devices we have on our robots. So the first two device you can see is X-ray fluorescent spectrometer and near-infrared spectrometer. They are located on the bigger one, on the transporter rover, and these devices, they can perform tests in situ. We don't need to collect samples, and they can tell us about some overall some how to say it, the components of the rocks of the surface that we want to test, and we are looking at first for some components which are related to the aqueous environment, because then it could tell us if water was there at some point, maybe in past, and that's interesting.
11 minutes.
Excuse me.
You are at 11 minutes.
Oh, okay. Thank you so much. Okay, I need to speed a bit. Okay, the next three devices, they are located on the laboratory, which is on the landing site. I didn't mention about it because it's not a part of robots. It is the site where the whole mission starts, and they need to have some sample delivered. So the robots, the Boston Dynamics, they have installed some drilling tool which allows us to collect a sample, which can be then transported to the laboratory, where we can perform some tests. And then we use Raman laser spectrometer, X-ray diffractometer, and also MoMA, which is a device that is already tested on some current missions to Mars. And these devices, they allow us to measure the components in more details, and we want to find some biosignatures, some organic compounds that can lead us to some more conclusions. But still, all the research that is performed by the robots, it's not complete. Also, our samples are collected, are packed and collected, and after maybe in some future missions, they can be taken by humans and researched in more details. Then we will find out more. Okay, I also wanted to show you some maps, because as I said, it's even if because we don't really know what we can expect. Lava tubes are not researched yet, and maybe the findings are very interesting, or maybe not. So we also made some plans what to do in the area where the mission happens. So here you can see we have some places where we want to check the caves, but also there are some craters and other structures that may be interesting for the future missions, and also for preparing for some for creating some human colonies in future. And at the end, I would like to show you the how looks from the more engineering point of view, such a transporter rover, just to show that the project is very broad. I only mentioned a very short part which I was working at, but there are also others who are focused on the robotics, also on some navigation studies and geological research, and that's how we succeeded. That there is just a lot of very talented people, and which can work together and have some success. Okay, and there is also some question you can think about, because at this moment Mars is only inhabited by robots, and what do you think? Will it change, or maybe we will also discover that there are some other forms of life? I will leave you with this question, and thank you so much.
Thank you a lot. That was very interesting proposition for the potential landing on the surface of the red planet. And please let me know if you have any questions to Aleksandra. I think I have some problems with the chat, so I cannot see some of the questions that that were asked for the previous speaker, so I'm very sorry for that. But if you have any questions for Aleksandra, I'm sure that Tomek can jump in and let us know. In the meantime, I will have my question related to a little bit of the geology of the area, because you need to, in order to investigate the lava tubes, you need to land where the lava tubes are, and all of them, if not all of the known ones, are at pretty high elevations, where it will be quite hard to land using the current techniques. So what can you say about how to land in those interesting locations that you selected?
But you mean the how to land the whole mission?
Yeah.
In the beginning. That's the question to myself. As I said, there were some other scientists which worked on the choice of the right side to land, and I think that we can ask them, and I can answer the question afterwards on the chat.
Oh, perfect. That will be great. Awesome.
Thank you very much.
Perfect. Thank you very much. If there are any other questions, please let me know. And I hope we can see if there are any other questions. Tomek, if you can see any questions that I cannot see, let me know very quickly. And if I will miss something, Aleksandra, you can just answer them in the chat. Okay, there are no questions. Thank you. As I said, I'm experiencing some strange freeze-ups in the system. Great. So what do you think is because you have suggested using a lot of different robots. How do you think, even managing a single robot on Mars, it's a challenge. So how are you going to manage entire herd of robots on Mars? Do you have any plans in your mission architecture?
Okay, so at first it was a plan that we need many of them because we, as I said, we don't really need what to expect inside of such a lava tube, and I assume that we will lost some of them, that they get destroyed, and some of them can get lost, and I think that it's more important to get a sample than to pay attention to a single robot. So that's why we have such a herd of many different robots, and that's also, like as I said, step by step. We start with some mapping of the area. These are some robots responsible for this part. Afterwards, there are some robots which can perform some tests in situ. There are also robots which collect a sample, which also there are the small robots which can go into very, very narrow tunnels to check what's inside. And also what I didn't mention is that the mission has also some contribution to future missions, because this way we can test what kind of robots work the best, and what can we improve, and that will be the point for the next missions.
Perfect. Thank you very much.